So in order to be able to overload an operator, the first thing that I need is the return value. So I'm going to have it return to me a distance object. I'm going to use the keyword operator and then the symbol or the sign that I am trying to overload, which is the plus. And then the parameter list is going to include, if I'm going to add two distances together, one distance is going to call it, and I'm going to try to add another distance to the one that's calling it. So I need to pass another distance object. So how about if we pass it, my parameter is going to be called D1, and then instead of doing the function inline like I did with display and my getters, we're going to come down below main and we're going to define those functions below main. So I'm going to copy my function declaration from lines 38 and 39. I'm just going to copy it down here. A couple of things that I need to do to clean it up. I'm going to remove that semicolon. And then I also have to, because it's being defined outside of the class, I need to use the access operator with the dual colons in order to be able to indicate that it is of the distance class. This function is from the distance class. All right, so we'll have my opening and closing curly braces. And what I'm going to do inside of here is to add two distances together. It would only make sense to add the feet together and then to add the inches together. So the first thing that we're going to do is I'm going to create a local variable called feet. And I'm going to set that equal to feet. And I'm going to add to that d1.feet. Oops, spell it right. d1.feet. So this feet right here is going to be literally, it's going to add this. If you remember this operator that we used before, add this feet and the parameter feet. So d1 is the parameter. This feet, I don't have to indicate this here because I am indicating the fact that it is a part of the distance class and there is some kind of an object that is calling it. So now that I'm going to add the two feet together, we're going to add the 2 inches. So I'm just going to repeat the process with inches on line 53. I'm going to create a local variable called in or inch, and I'm going to add this, the calling object's inches, to my parameter inches. Maybe it would have been less confusing if I had called my parameter something different than the objects that I declared in main. So we could call this distance 1, and then instead of d1, I could call this one distance 1 and this one also distance 1. If it makes it less confusing that I am doing the calling objects feet plus the parameter objects feet. All right, but we can't just leave it here, right? Because what happens if the inches is overflowing 12? We definitely know that we can only have 12 inches, or actually 12 inches becomes a foot. So what I need to do is to roll over the inches, and I'm going to use that with a while loop. So I might say something like while inches is greater than or equal to 12. We're going to roll it down. We want to increment feet, right? So I'm going to say inches minus equals 12. So I'm going to subtract 12 off the inches, and then I'm going to increment feet. And that way, if we can actually have a correct response. And then once we're done with that, this would be our end while. And once we're done with that, we are going to return a distance with feet and inches. So what you may have noticed is that we are now returning a brand new distance object. Oh, that should be a comment. We are going to return a new distance object. And since the scope of this distance object, so I'll put an end function here. I'm going to put a comment on here that says we are going to roll over the inches because I don't want to be 19 inches, 7 feet and 19 inches. So let's run it, or we're going to have to call it down in main. So let's go down into main. Let's see if we could add a couple of inches together. All right, so I meant we're going to add a couple of distances together. So I'm going to go down here into main, and I'm pretty sure that D1 was set to nothing or zeros. So D2 and D3, I can see if I add the two of them together, it should be 13.75. Let's run it after I've added the two of them together and see if that's what we get. So we'll display it and then run it and see if we are getting 13 feet, 7.5 inches. So what I see here is the statement distance object destructed. So remember when I said our destructor is going to destroy an object when it goes out of scope? Well, we had a function. As soon as we left the function, it is going to destroy our object. And then if you'll notice all of the other objects that are being destroyed as the program is ending or at the end run of the program. And then we do have the display where it added the two of them together. So I probably need to clean that up a little bit. And I'm actually going to remove that object being destructed from our destructor because it makes it a little bit tedious through a run of our program. So if I run it one more time, see if I still need to put in some distancing between the print statements, and there it is. So this is the addition, 13 feet, 7.5 inches when it added these two together. All right, so let's see if we can overload the less than to see if one distance is less than another distance. So the outcome, the return value for this one is going to be a Boolean, true or false. Is one less than the other? So it is going to have a Boolean return value. We're going to use the operator keyword, and then we're going to do the less than symbol. There would be one parameter is the distance. We will call, how about if I call that this one, just to make it a little bit clearer, our parameter. So there is an object that we'll call it, and we're going to compare it to a parameter object. And then I will copy this, and I'm going to paste it down here. There's main. So I am going to define that outside of main. In order to be able to do that, we have to tell it that it is a part of distance. And then I'm going to remove that semicolon, and then we'll have our opening and closing curly braces. And what I'm going to do inside of here is how do we decide whether or not the one that is calling is less than the one that is being called? Well, it seems like one of the ways that we can do that is we could convert each object to a float, and we could compare the floats. So feet and inches, if I convert those both to a total length for each one of the two, and then I compare those total lengths, then we could tell if the calling is less than the comparison. So we are going to create a float variable. I'm going to call it this length because this is the one that is calling this function itself, which is actually going to be on the left-hand side of the comparison operator. And so the instance variable is feet, and then I need to divide the inches into a floating point, add the two of them together, and then we're going to repeat the same process for the parameter object. So now I have a float variable called parameter, a local variable called parm length or parameter length. So now I'm going to use the parameter to add the feet to its floating point inches, and then I should just be able to compare this length to parameter length. So I'm going to use the ternary operator to return either a true or a false based upon whether or not this length is actually less than my parameter length. And then I'm going to come down here and let's give it a try. So we're going to compare two distances. And then it's going to return a true or false, right? So I have my if statement. If D1 is less than D2, we're going to see out D1 is less than D2. Otherwise, we're going to say D1 is greater than or equal to D2. So I have my if else statement. I'm going to run it, and the expectation is that D1 is greater than or equal to D2, because because we added D2 and D3 together and put it in D1. So if D2 is 12 feet, 6.5 inches, D1 is now 13 feet, 7.5 inches right there. All right, so the next thing that we're going to do is we are going to overload the IOStream operators.